the reason we started with water rather than snow skiing, for example, is that water's a flat surface. It's a 2D surface, and there's no obstructions, there's very few people around, etc. So right now, yes, it absolutely does. The problem is there's a lag. So like, I gave you the example of windsurfing. Windsurfing turns out to be super easy. Kite surfing, on the other hand, is much harder because you kind of swing like 30 feet in the air. So in this case, we're not going to be able to move the copter fast enough. There's like a 1 second latency between the various GPS and communications, et cetera. What we can do is move the camera. So what happens to the position to yourself? So one of the things we're actually doing is on the Follow Me box, there's probably going to be, there's a rocker, a 4-position rocker. And so when you tell it to come out to you, you sort of say, do you want it to be here, 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 or here? Depending on the wind and the sun, you want to get the right angle. And in the case of kite surfing, the kite's probably going to be, it's going to be, the wind's coming this way, the kite's going to be ahead of you. So you don't want the kite to be obscuring, so you put it over here. So when you like flying in the air, the camera will track you. That's not, it's be a little slow, but we tend to use these wide-angle lenses. So there's a half-second delay. The aircraft typically will not track you. So that's for water. For skiing, we're a little more concerned about that because a couple things. First of all, the terrain is very unpredictable. Second of all, you got trees, and third of all, you got other people around. Terrain following is not hard, but it's because we have the topology from Google Maps. But what we're more concerned about is things that are not on maps, unpredictable obstructions. And so we're not going to enable terrain following on day one simply because we don't want people to be unsafe. But water. Oh, the other thing, by the way, is we insist that we've disabled automatic takeoff and landing for the Follow Me function because fundamentally that thing's sitting on the beach. We don't want the props to spin up at some random time. So we make your buddy sit on the beach, take it off manually, put it in loiter mode, and now it's ready for the Follow Me button to be pushed. And when it's done, it returns to loiter mode on the beach, waiting for someone to switch it back into manual and land it when it's safe. We have the optical flow software is ready. We actually have a new optical flow blower coming out that has a really awesome chip. It actually uses optical flow, by the way, is a way. Does anybody have a paired AR drone? Yeah, so you know how when it looks down, it holds its position by looking. Optical flow is what an optical mouse uses. It just looks at the movement of pixels and turns that into a vector. Our new optical flow board uses a camera chip, which has a lot of pixels, and then just moves an optical flow window around the camera, around the big CCD with a fisheye lens that gives you a 180-degree field of view. So that's the PX4 Flow one. But our current optical flow chip is supported on the current board. So I told you that technology has never moved faster than it's moving in smartphones. LiPos, unfortunately, are the slowest part of all of that. It's really hard to compete with gas for energy density, et cetera. So I think copters are going to be in the sort of 15 to 20 minute range for a while yet. You want more distance or time, you go for a plane. You want more distance and time yet, you go for a gas engine. So I wish there were Moore's law of LiPos, but it's slow progress. General purpose technologies, or all technologies, can be used for good and for evil. Personal computers can do wonderful things, and they create computer viruses. You can build a house with a hammer, you can hit someone on the head with a hammer. I think that our responsibility as technologists is to inform the world about what these technologies can do, to inform the regulators and the law enforcement agencies about what they can do, but not to limit the technology themselves. First of all, ours is open source. We could put in, we could put limits in the code to say how you can use it and how far you can go, but it's open source, so people can take out those limits. So there's almost nothing we can do to stop people from using it from ill. What we do is we've reached out to all of the agencies, CIA, NSA, Pentagon, et cetera, and we get like a quarterly briefing with the FBI where we tell them what's going on, what's possible. We have a deal, and we've disclosed this to our community, that if we see anybody in our community doing something, talking about uses that we consider dangerous or possibly terrorist-like, we will actually call the FBI and tell them about it. When the FBI gets in contact with me, which they sometimes do, we will point them to anything that we see. Now, we don't know very much about our users. All we know is their email address and their IP address. But we will give that to the FBI. We've been very transparent about this, that what we want to do is we want to bring this behavior in, we want to bring UAV use into the public light. We want to sort of shine a spotlight on what's going on out there to inform those who are trusted with protecting us about what's possible. So rather than limiting the technology and pushing it underground, we illuminate the technology, make it really easy for the agencies to see what's going on, to let them do their job to protect us. So in a sense, what we believe in is preventing the bad use rather than the technology itself. And as an open platform, there's actually nothing we could do about it. And I think this is largely the Silicon Valley model. You know, we don't lock down computers so they can't be used for ill. We just prosecute people who do use them for ill. So someday somebody's going to do something bad with our technology. We know that. But we would like to believe that by having so many eyes on the use of the technology, that other cases will be spotted ahead of time, and that you know, the law enforcement people can jump in on it very, very quickly. So we take our responsibilities to inform the government about what's going on very seriously, and you know, I fly to Washington all the time to brief them on this, and so far they've been appreciative and supportive of what we do. As you know, Congress has given the FAA a mandate to bring commercial use with certain restrictions into the national airspace. We would like to enable a huge industry of people applying this technology in various verticals. Let me just give you one example, agriculture. We have a team right now who are working with our technology in Davis, who are just tromping around wheat fields all the time. So when people think about drones, and I shouldn't use the word drone, and I know they're UAS or UAV, but common language calls them drones. When people think about drones, they think about, you know, manned aircraft-sized predators, things like that in the sky, cameras, etc. I think what's most likely is they're going to be driving around farm fields around here and see small airplanes and quadcopters just flying around doing crop surveys, maybe even crop dusting, like a crop duster today. You actually don't even need infrared, just an optical. It turns out farmers know almost nothing about their crops. Now, you know, I'm not a farmer, and I'm probably overstating, but basically it's very hard to get a full, holistic view of what's going on everywhere on your farm. Farms are big, it's hard to get to them. You've tried to walk through a cornfield, you know it's not easy. And so what they do is they sample, they spot check and that kind of stuff. What they really want is an overhead view. Actually, even just optical, even in the visual spectrum, it's fine. Farmers are really good at knowing that brown is bad, or that, you know, this color is not what they want to see. What they don't have is a daily or weekly, you know, a view of their entire farm. And so we've been doing these experiments, and as a result, in the absence of knowing for sure that there's no wheat blight in the farm, they end up using too many herbicides, too many chemicals, too many herbicides, too many fungicides, too many pesticides, in case something bad's happening, because they don't know if something bad's happening. You put a drone, and we're talking about a foam plane about this big, that you just throw out the window. It's automatically programmed to do a kind of lawnmower pattern. The data is then stitched together, and the farmer then looks, you know, basically throw the drone out the window, have breakfast. By the time breakfast is done, you've got an aerial view of your crop in high resolution, and you're like, looking good. Or you're like, whoop, brown patch, got to go check it out. And that kind of information allows us to use less chemicals, it's cheaper, it's just a better thing all in all. That's a great example of a commercial application. And there are some of our friends from the agricultural world are here today. It's a great example of a commercial application which is not competing with man. This job is not being done at all right now. This is a way to kind of create industries, create jobs by using autonomy for what it's good at, which is jobs that are really boring and jobs that are just too, you can pay someone to do it right now, but it'll cost $1,000 an hour. This is a way to use autonomy to do cheap access to the sky to create industries that don't currently exist. We know that, as you say, this box will soon be a chip that's in every one of these. And we know that that chip will do the geofencing, it'll do the return to launch. We also know that all those acrobatics, you know, I know we're seeing some amazing demos out there. It's just a button. There's no, you know, robotic or scripted acrobatics is simply a trivial, you know, software function on top of this already. So given that robots fly planes better than people fly planes, and given that they can do things that are impossible for people to do, what is the role of the hobbyist? What's the role of the pilot? Well, initially what we're doing is we're treating it as a STEM project, which is a way to teach engineering and programming and robotics, et cetera. So we're going to be launching so right now, the problem with the airplanes and the copters is that they're a little bit dangerous, especially for like high school and middle school students, and they typically need to do it outside. So it's weather issues and some FAA issues and safety issues, et cetera. We're going to be launching a blimp, an autonomous blimp. We started with an autonomous blimp a couple of years ago, and by autonomous, that means it does what's called SLAM, simultaneous location and mapping. It navigates outside of a GPS route, so you don't have GPS inside. So it navigates inside based on its own sensors. The problem is that we didn't have a good way to do that. In our new one, we're using this optical flow technology that we're talking about, which is basically cameras. It's going to cost under $100, and blimps are wonderful. They're like whales. They're really beautiful. They're slow. It doesn't hurt you. They sleep on the ceiling. Like at night, they sleep on the ceiling, and you come in, and they bring them down. So they're natural flyers, and so we think that's a great way to teach kids about aerial robotics. But I mean, it's a great question. So right now, our drone competitions, and Lucian Miller and others are doing the multi-copter rodeo later this year, and we're going to have a drone competition there. Right now, the technology is challenging enough that simply programming it is the competition. But when it's as simple as, you know, a chip that's pre-programmed with every acrobatic you can imagine, what's the competition going to be then? I don't know, but I count on you guys to figure it out. So the bad news is that you don't have to have skills to fly anymore. The good news is that you don't have to have skills to fly anymore. So it's you know, what you might see is that people come into the hobby not because they want to pilot, but because they want an aerial view of something. They think of it like, you know, a Google Maps, you know, experience, or maybe it's just like, you know, look at the GoPro videos out there. It's a YouTube. Maybe YouTube is the biggest driver of the RC hobby in the future because we get advantages we never could have had before because the piloting part was too hard. So I think when you think about what we do is basically turning this plus a GoPro is an aerial imaging platform, and as a way to kind of give a GoPro camera wings, that becomes a very cool, exciting thing for a generation we probably want to bring into RC. Not in the same way that, you know, it's coming in for a different reason, but I think it is a reason.